Hello? Hello? Is it audible? Anybody?
Yes, sir.
Okay. Is the screen is visible?
Yes, sir.
Okay. So 3-4 days back, we have discussed about the single phase electrodynamometer for the measurement of power factors. Actually, I have explained about the basic things also. So in the three-phase electrodynamometer power factor meter, whatever the angle of deflection is there, that one we have to tell that angle of deflection theta should be directly proportional to the phase angle between voltage and current here now. So by using this one, the cosine of this angle, which is going to give the value of the power factor, that is called cos phi. We are going to get that here. So to identify, to measure this cos phi is nothing but power factor, we are going to use a electrodynamometer. We are going to use here. So electrodynamometer. For this electrodynamometer, if we have given single phase supply, then it will become single phase. If we have given three phase supply, it will become three phase. The load is there here. This consider this one here. The supply is there. This side. If only two lines are there, so the single phase two wire we have going to consider, that is called single phase electrodynamometer. And we already know that in an electrodynamometer, it has two coils. One is fixed coil, another one is fixed coil, another one is moving coil. Yes or no? Is it audible?
Yes, sir.
So one fixed coil, another one is moving coil. But this one fixed coil, we are going to make into two parts. First half we are going to keep at the upper side. Another half we are going to keep at the downside here. Number of turns or windings, we are going to make this one into two parts here. So the identical two moving coils we are going to consider here now. Both the coils are connected each other here now. So which is connected to the spindle, and the spindle is connected to the pointer. We are going to call that one here. Two moving coils are there, coil A and coil B. Coil A and coil B. The reference plane we have taken here now. Based on this, the angle of deflection, that is called theta, we are going to measure here now. Based on the phasor diagram, the angle between voltage and current we are going to get here now. From this one we will get one equation. From this one we will get equation based on the torque equation 1 and torque equation 2. By simplifying those both the equations, we are going to get the final equation, that is called theta is directly proportional to the phi here now. So we have discussed this one in the previous class. I think we have already discussed this one. Discuss किया क्या नहीं?
Yes, sir.
Okay. So I have shown the diagrams here now. So by here the TB equation we have written, TA equation, torque equation of the coil A and torque equation of the coil B we have to do. After rearranging some, applying some mathematical formulas, we are going to get that is theta equal to phi here now. So don't concentrate much on this one, how we got this theta equal to phi. It will nearly one phase derivation will come again. For this one it is okay. For three phase it will take so much time for the derivation and all the things. For the offline session, okay, but for the online, here directly you can write that one. By simplifying this equation, we are going to get theta equal to phi. You can write here. So this theta is deflection, phi equal to, what is the phi? Theta is deflection, angle of deflection. What do you mean by phi? From the diagram you check that one. Where is the phi? From the phasor diagram you can check it. Where is the phi? Here it is a 5 value only. Yes or no?
Yes, sir.
What is this? It is an angle here now. So angle between what is it consist here now from this point to this point? What is this point? This one means which line it is?
Voltage.
And this line?
Current.
So the angle between voltage and current here. That is called phase angle or angle we are going to call that one here. So the deflection is directly proportional to the phase angle of the circuit. We can call that one here. Also by using this one, we can measure the power factor here. So what I will tell here now, this diagram you look at carefully, you just observe in the, say, remember this diagram. The same diagram, if I applied the three-phase supply, then how it is going to operate?